Software development relies on a single foundation. Millions of developers push code every day, trusting that the platform hosting their work is secure, stable, and accurate. That platform is GitHub. The workflow is muscle memory. You write your code, you push the update, and the continuous integration pipeline takes over. When the interface returns a bright green checkmark, you know your work is safe and ready to ship. On the afternoon of April 23, 2026, thousands of developers went through this exact routine. They reviewed standard, mundane code updates, clicked the merge button, and saw that familiar green check. This split screen shows what was actually happening. On the left, the interface tells you a routine 30-line update merged perfectly. On the right, the database log shows the system actively erasing hundreds of lines of critical code. There were no error flags, no conflict warnings. In a matter of hours, the system silently corrupted over 2,000 pull requests across nearly 700 repositories. Months of active team progress simply vanished. When a server crashes, work pauses. But when a platform actively lies, telling you a destructive deletion was a successful update, it breaks the core trust required to build software at scale. That silent deletion was just day one. Over the next 5 days, GitHub endured a series of escalating failures that exposed systemic flaws across its architecture. The code deletion was caused by a bug in the merge queue feature. When a developer queues up an update, the system creates a temporary staging branch to test how the new code interacts with the main project. Instead of staging from the latest code, the bug forced the system to pull from the exact moment the feature started, weeks in the past. The queue then merged that outdated ghost branch. Everything built in the interim was wiped clean. 4 days later, on April 27th, GitHub's search cluster collapsed. The core code survived, but the entire interface we use to navigate it, pull request lists, project boards, and issue trackers, went blank. Then on April 28th, security researchers published CVE 2026-3854. This was a critical vulnerability with a severity score of 8.7 that allowed any logged-in user to run commands on GitHub's backend. The attack was simple. A user sends a standard command to upload code containing a hidden semicolon. That character tricked GitHub's proxy service into ignoring security headers, dropping execution commands straight into the shared storage nodes. This oversight exposed millions of private and public repositories to complete takeover. It was discovered using AI-powered reverse engineering tools that ripped through GitHub's compiled code in a fraction of the time a manual audit would take. A multi-billion-dollar infrastructure does not typically suffer 3 cascading catastrophic failures in a single week by coincidence. The underlying cause of this instability was a massive, sudden surge in traffic generated by automated AI developer agents. This graph illustrates GitHub's capacity planning. In late 2025, they projected a 10 times growth curve for new AI tools. But automated traffic from agents blew past that projection, peaking at 90 million pull requests and over 1 billion commits. These agents don't sleep. They constantly query servers, test code, and open pull requests. This relentless wall of automated requests effectively functioned as a continuous, self-inflicted denial of service attack on the platform. This load hit GitHub's primary engineering bottleneck, a massive central codebase written in Ruby that could no longer distribute the work efficiently. The system's components were so tightly linked that a crash in the search cluster immediately paralyzed the project management interface. These AI tools did exactly what they were designed to do, rapidly increase developer output. But in doing so, they shattered the physical limits of the infrastructure hosting that code. When the tools you rely on actively destroy your work, developers leave. This week of unreliability triggered a wave of departures from the platform. The maintainers of the Zig programming language migrated their operation to Codeberg, citing severe bugs in GitHub's automated systems. Soon after, major projects like Ghostty followed suit. To stop the bleeding, GitHub's engineering teams initiated an emergency overhaul of their entire system architecture. They halted all new feature development to focus on stability. They are now rewriting their primary code base into Go for better performance, and installing new back pressure systems to physically block traffic when the servers overload. Developers can no longer treat a platform's visual interface as the absolute source of truth for their code. You have to verify your code. Spot check your merges to ensure what landed matches what you approved. Immediately establish local backups of critical repositories. And if your team runs a GitHub Enterprise server, patch it today. Artificial intelligence has drastically accelerated the speed at which we write and deploy code. But the greatest vulnerability we face right now isn't the code we generate. It's our blind reliance on the platforms holding it all together.